presentation in industry. Welcome your presentation.
Hi, thank you. Start the presentation. You can see my screen?
Yes.
Okay. So, dear fellow speakers and listeners, my name is William Dumoulin, and I'm here to present you the work I made with my co-writer, Nicolas Thierry, and our professor, Rims Lama. We are students from a mechanical engineering university in Belgium, and this is the work we made in a school project. So to give you a bit of context, there are different levels of human-robot interaction: coexistence, synchronization, cooperation, and collaboration. Collaboration is the highest level of interaction where robot and operator share the same space and work on the same component simultaneously. In this context, we need a specific algorithm able to recognize gestures in order to control a cobot without a control panel. I will start by describing the dataset and its creation process. I will then explain the pre-processing techniques that we used. After this, I will present the model and then the result by showing you the confusion matrix. I will finish by talking about the real-time prediction. We decided to create our own dataset of 10 gestures, from which you can see 9 on the screen. There are simple movements like opening and closing a hand, and more complex ones like the explosion and the crossed fingers. We can imagine a specific application of a robot arm controlled by our program. Opening and closing a hand can open and close the claw, and swipe to the left and swipe to the right could make it turn. The idea behind our research is to show that we can create any gestures we want and train a model on it. The only limit is imagination. In an industrial context, anyone can invent new meaningful gestures for each specific application. There are some protocols in the dataset creation process. We need at least 12 different people, and each one must do at least each gesture twice. We wrote a small Python script to create the dataset efficiently. With a good rhythm, we can create 10 videos per minute. We gathered a total of 1,500 videos that make 150 videos for each type of gesture. Each video has exactly 61 frames, which last 2.4 seconds, as we found it was long enough to make any gestures. I will explain in a minute why the specific value of 61. We want to analyze only the gesture. We don't want to keep information about the background or the person who made the gestures. Therefore, we isolate the movement between each frame. The process is very simple. Each frame is converted from RGB to grayscale. Then we calculate the distance between each pixel of the two nervous frames. The next step is to resize the image to a smaller scale. And finally, the value of the pixel is normalized between 0 and 1, so we can give it to the model. When we isolate the movement, we compare each frame with the next one. At the end, there is no image left to compare the last one with. That produces 60 frames of movement. This number is divisible by 2, 3, 4, 5, 6, and so on, and that gives us the opportunity to isolate a smaller number of frames from the original videos. That will be useful for experimentation. We decided to use convolutional layers combined with LSTM, as we found that they were powerful. Convolutional layers are efficient to find features in images, and LSTM stands for long short-term memory, and is efficient to recognize pattern in a sequence. And that's exactly what we want because we are analyzing video. We based our first model on the work of Hakim et al., but we didn't get a good accuracy. So we modified the structure of the model by adding or removing some layers, and then we tweaked the parameters of the model and of the pre-processing until we obtain a good accuracy. By tweaking the parameters, I mean the number of kernels in the convolutional layers, the size of the dense layers, and the value of the dropout. In the processing, it's the number of frames per second that you kept and the size of the image. As we explained earlier, we have 60 images per video that can become 10, 15, or 20 frames. And for the size, the original video is 640 by 480. And after our rescale, it's 120 by 90. With this reduction, we reduce the computing time and the complexity of the model. Because we didn't have an infinite number of video to train our model with, we used all the data to train it. And then we created the challenging videos to measure the efficiency of the model. When we know exactly which videos is used to train the model and which one is used to test it, we know the model, the efficiency of the model is not influenced by the videos, but only by the inherent parameters. Another reason for this manual split of the training and test data is to make sure that all the videos done by one person will not make the whole test data. Here is the confusion matrix of our model. As I just said, we had specific videos to test the model on, 13 videos for each gestures. And we found that opening and closing hand are often confused with one another. Opening and closing hand is the label 0 and 1 on the confusion matrix. We can see that both of these gestures are done on the same place of the video, and they are the difference between both is very more subtle than between all the other gestures. So for all the other gestures, the model is efficient with on the live test, we often got a precision greater than 90%. So the overall accuracy is 84%. However, other works that are using different pre-processing techniques have a higher accuracy. Some works reach an accuracy of from 95 to 98, but used advanced pre-processing technique. So we think it might be interesting to continue our research on this pre-processing method because it gives correct accuracy with a simple pre-processing technique. We created a user-friendly interface to show the result of the prediction in real time, but it's still very computationally expensive. On my laptop, it takes 2 seconds to make up one prediction on the CPU and 0.4 seconds with the GPU. We added the possibility to add new videos on the run, and it's possible to train the model from the interface. We also can see a feedback from the camera, as well as the 3 predictions with the highest recognition rate, and the number of frames that are already recorded in order to know when the recording starts and when it ends. If I have some time left at the end of my presentation, I can talk more about the interface. As for the non-gesture class, we considered as no action the actions with a recognition rate less than a threshold. The threshold is fixed at 60%. To conclude this presentation, I can say that we created a program to record the videos in order to create our own dataset, which is made out of 1,500 videos. During the pre-processing step, we isolated the movement between each frames of the video. Our model is made of layers such as convolution and LSTM. And the result you obtain gives us an overall accuracy of 84% and 90% for 8 gestures out of 10. In future work, we intend to collect more data in the industrial context using our developed interface. We also have to focus on resolving the problem of gesture confusion by improving the model performance. Thank you for your attention. I hope you found our project interesting, and I'm ready to answer any questions.